Ollama makes running a language model on your own machine a single command, and that is genuinely a small miracle. It is also why so many people's first experience is disappointment. They pull a model, it runs at 3 words a second, the answers are noticeably worse than the API they are used to, and they conclude local models are not ready. Sometimes that is true. Very often it means they picked a model that does not fit in their graphics card, and nobody told them how to check. So this episode has a spine, the arithmetic. If you learn one thing, learn how to work out whether a model will fit in your VRAM, because that single calculation decides whether local inference is a delight or a crawl. 9 concepts. 1 running example. You have a laptop with 16 gigabytes of RAM and an 8 gigabyte graphics card, and you want a useful coding assistant that never sends your code anywhere. And you will know exactly which model to pull and why. Set up this first, because most people should just use the API. A hosted model from a frontier lab is smarter than anything you will run locally. It needs no hardware, and it costs pennies for most workloads. So what would make you run your own? Privacy, and this is the big one and the honest one. Your code, your customers' data, your medical records, your legal documents. Some data cannot leave the building. And it does not matter how good the API is if you are not allowed to call it. Cost at volume. An API is cheap per call and can be expensive at 1 million calls a day, and a machine you already own has a marginal cost of roughly 0. Latency and offline. No network round trip, and it works on a plane. Control. The model does not change under you. No silent upgrade that breaks your prompts. No deprecation. No rate limit. And experimentation. You can pull a dozen models in an evening and compare them for free. And the honest counterweight, which I will keep repeating, the model you run at home is meaningfully weaker than the Frontier API. It is slower unless you have real hardware and you are now the one operating it. Run local because you have a reason. Do not run local because it feels more serious. Concept 1. What Ollama actually is, and what it is a wrapper around. Ollama is 2 things. It is a local server that loads models and serves inference over an HTTP API on your machine. And it is a registry and a command line tool that makes fetching and running those models trivial. Ollama pull, Ollama run, Ollama list. The Docker comparison is not marketing. It is genuinely the right mental model. A registry of pre-built artifacts, a simple pull and run interface, and a declarative file to customize one. Under the hood, Ollama is a wrapper around llama.cpp, which is the C++ inference engine that does the actual matrix multiplication. And it is worth knowing that because it explains what Ollama is and is not. What it gives you is packaging and ergonomics. It downloads the right quantized weights, sets up the prompt template that the model expects, manages memory, and serves an API. What it does not give you is a new inference engine or better quality. If you have used llama.cpp directly, Ollama is convenience, not capability, and a useful detail. It exposes an OpenAI compatible endpoint, which means most tools that speak to OpenAI can be pointed at your laptop by changing one URL. That single feature is why Ollama won. Concept 2. What 7b actually means, and why it is the number that matters. When you see Llama 3.1, 8b, that 8b means 8 billion parameters. 8 billion numbers that constitute the model's learned weights. And that single number tells you most of what you need to know. It predicts the quality. More parameters generally means a smarter model, more world knowledge, better reasoning. It predicts the size on disk, and, critically, the memory it needs to run. And it predicts the speed, because generating each token means reading every one of those weights from memory. So a model twice as large is roughly half as fast. Here is the rough map of what you get at each scale. 1 to 3 billion, fast, runs anywhere, fine for classification, extraction, simple summarization. Do not ask it to reason. 7 to 9 billion, the sweet spot for consumer hardware, genuinely useful. And this is where most people should live. 13 to 14 billion, better, and now you need real VRAM. 30 to 70 billion. Approaching serious capability, and you need a workstation or multiple cards. And beyond that, you're in data center territory, and you should be using an API. So the number in the name is not a spec sheet detail. It is the single most important thing about the model, and it is the input to the calculation we are about to do. Concept 3. Quantisation, the compression that makes local inference possible at all. A model is trained with each parameter stored as a 16-bit number. So an 8 billion parameter model at 16 bits is 8 billion times 2 bytes, 16 gigabytes, just for the weights. That does not fit on an 8 gigabyte card, and this is why so many people's first attempt crawls. It spilled the system RAM. Quantization is the fix. You store each weight with fewer bits, 8 or 5 or 4, and you accept a small loss of precision in exchange for a large reduction in size. At 8 bits, that 8 billion model is 8 gigabytes. At 4 bits, it is about 4. You have made it fit. And the crucial empirical finding, which is genuinely surprising the first time you meet it, the quality loss is much smaller than you would expect. 4-bit quantization typically costs you a few % on benchmarks, and it makes the model run at all. So the practical rule that matters more than any other in this episode: a larger model, heavily quantized, almost always beats a smaller model at full precision. A 13 billion model at 4 bits beats a 7 billion model at 8 bits, and it uses similar memory. Reach for the biggest model that fits quantized, not the biggest model you can run unquantized. In Ollama's tags you will see things like Q4_K_M, that is 4 bits, and it is the sensible default. Q5 if you have room, Q8 only if you have plenty, and below 4 bits, quality really does start to fall off a cliff, so do not be tempted. Concept 4. The calculation. This is the concept that will save you the most frustration. Here is the estimate, and it is simple enough to do in your head. Memory needed, in gigabytes, is roughly the number of parameters in billions times the bytes per parameter, plus overhead. Bytes per parameter, 2 at 16-bit, 1 at 8-bit, and about 0.5 at 4-bit. So, an 8 billion model at 4 bits is 8 times 0.5, which is 4 gigabytes. Plus perhaps 1 to 2 gigabytes of overhead for the KV cache and the context. Call it 5 to 6 gigabytes total. On an 8 gigabyte card, that fits comfortably. Now a 70 billion model at 4 bits. 70 times 0.5 is 35 gigabytes, plus overhead. You need a 48 gigabyte card, or two 24 gigabyte cards. That is not a consumer laptop, and no amount of wishing changes it. And here is why this matters so much, and it's the thing nobody warns you about. If the model does not fit in VRAM, it does not fail. It falls back to system RAM and runs on the CPU. And it is not a bit slower. It is 10 to 20 times slower because system RAM has a fraction of the bandwidth to video RAM, and inference is entirely bandwidth bound. That is the 3 words second experience, and it is why people conclude local models are useless. They're not. The model just did not fit. One more thing. Your context window costs memory too, and it costs it quadratically as it grows. Running a long context on a nearly full card is how a model that loaded fine falls over an hour later. Concept 5. Which model to actually pull? 2 rules applied in order. First, it has to fit. Everything else is irrelevant if it does not, so do the arithmetic first. Second, match the model to the task, because general chat models and specialized models are genuinely different and people ignore this. For code, use a code model, the Q1 coder family or CodeStrol or DeepSeek coder. A 7 billion code model will beat a 13 billion general chat model at code every time, because it saw far more code. For embeddings, use an embedding model, not a chat model, Nomic embed or similar. They are tiny, they are fast, and using a chat model to make embeddings is a category error. For structured extraction, a small model with a strict grammar is often better than a big one, because you have constrained the output rather than hoped for it. And for general chat, the Llama and Q1 and Mistral families are all reasonable, and you should try 3 and pick, because benchmarks are noisy and your task is not the benchmark. So, our worked example, 16 gigabytes of RAM, an 8 gigabyte card, and you want a coding assistant? The answer is a 7 or 8 billion code model at 4-bit quantization. About 5 gigabytes, it fits in VRAM, it is fast, and it is genuinely useful for completion and explanation. It is not going to architect your system, and if you expected that, you expected the wrong thing. Concept 6. Customizing a model, the Docker file of the pattern. The model file is where the Docker analogy pays off completely. It is a small declarative file. From names a base model, system sets a system prompt baked into the model so you do not have to send it every call. Parameter sets defaults, temperature, context, length, stop tokens. Template defines the chat template, which is the exact format of special tokens the model expects, and getting that wrong produces subtly bad output that looks like a dumb model rather than a formatting bug. An adapter attaches a low array, which is how you use a fine-tune. Then Ollama create, and you have a new name model. What is it actually for? Packaging a persona or a role so your whole team pulls the same configured assistant. Locking down parameters. Temperature 0 for extraction, so nobody accidentally gets creative output in a pipeline. Setting a context length appropriate to your hardware, which is a real memory lever, and attaching a fine-tune you trained elsewhere. Be clear about what it is not. It does not change the weights, and it does not train anything. It is configuration, and everything in it you could also do at call time. What it buys you is that it is now baked in, versioned, and shareable, which is exactly what a Docker file buys you, and for exactly the same reasons. Concept 7. Building on it, and the one line that matters. Ollama serves an HTTP API on localhost port 11434. It has its own native endpoints, /API/generate and /API/chat, which are simple and fine. But the feature that actually matters, and the reason Ollama is everywhere, is the OpenAI compatible endpoint. Take any code that uses the OpenAI SDK, chained the base URL to point at localhost, put any string in the API key field because it is ignored, and set the model name to whatever you pulled. That is the entire migration. Your existing application, your RAG pipeline, your agent framework, your IDE extension, anything that speaks the OpenAI API now talks to a model running on your laptop with no code change beyond a config line. That is a remarkable amount of leverage from one compatibility decision. 2 practical things. Streaming works, and you want it, because local generation is slow enough that watching tokens appear as the difference between feeling responsive and feeling broken. And keep alive. Ollama unloads a model from memory after a few minutes of idleness, which means the next request pays the full load time, several seconds, while it reads gigabytes back off disk. If you are serving something interactive, set a longer keep alive or you will confuse a cold load for a slow model. Concept 8. The honest limit, and they are real. The gap is real and pretending otherwise wastes your time. Quality. An 8 billion model at 4 bits is not a frontier model. It hallucinates more. It reasons worse over long chains. It follows complex multi-part instructions less reliably, and it will confidently produce plausible nonsense on things a frontier model handles. If your task is hard, local will disappoint you, and that is not a configuration problem. Speed. On a consumer card, you might get 30 to 60 tokens a second on a small model, which is fine for chat and painful for anything batch. Throughput. One machine serves roughly one user at a time. Ollama is not a serving platform, and if you want to serve many concurrent users, you want the LLM, which is a genuinely different tool built for that. Context. Long context is memory hungry, and the model that fits at 4,000 tokens may not fit at 32,000. And operations, it is now your job. Updates, model management, the hardware, the driver, the thermals. So the shape of the honest answer. Local is excellent for private data, for high-volume simple tasks, for development and experimentation, and for offline work. It is not a drop-in replacement for a frontier API on hard reasoning, and the people who tell you it is are usually selling something or have not tried it on a hard problem. Concept 9. The pattern most people should actually adopt. The framing of local versus API is a false binary, And the mature answer is that you use both and you route between them. Route by sensitivity. Anything containing customer data, source code, or anything regulated goes to the local model because it physically cannot leave the machine. Everything else can go to the API. That single rule solves the privacy problem without giving up quality where privacy does not apply. Route by difficulty. Use the local model for the easy, high-volume work. Classification, extraction, summarizing, routing, simple rewriting, which is most of the calls in a real system, and send only the genuinely hard reasoning to the frontier API. You will often find that 80 or 90% of your calls are easy, and that is 80 or 90% of your bill gone. Route by cost. Bulk processing locally, interactive quality online. And there is a lovely pattern in that. A small local model as a first-pass filter or classifier, deciding what is worth sending to an expensive model and paying for itself immediately. So the answer to should I use a llama or an API is yes. Use the local model for what it is good at, which is more than people think, and use the API for what it is good at, which is the hard part. The engineering skill is not picking a side, it is knowing which calls are which, and that is exactly the kind of judgment an interviewer is listening for. Let us put it back together. Ollama is Docker for models, a registry, a CLI, and a local server, wrapping llama.cpp, and it won because it speaks the OpenAI API, so pointing your existing code at your laptop is a one-line change. The B in the name is the whole story. It predicts quality, size, and speed. Quantisation is what makes any of this possible. And the rule that matters is that a bigger model heavily quantized beats a smaller model at full precision. Reach for 4-bit, and do not go below it. Then do the arithmetic before you pull anything. Parameters in billions, times bytes per parameter, plus a gigabyte or 2 of overhead. If it does not fit in VRAM, it does not fail. It silently falls back to system RAM and runs 10 to 20 times slower, and that is the 3 words a second experience that makes people give up on local models entirely. Match the model to the job. A 7 billion code model beats a 13 billion chat model at code. The model file is a Docker file, configuration, not training, and be honest about the gap. Then stop choosing sides and route. Private and easy goes local, hard goes to the API. Next in this series, fine-tuning and when not to. Subscribe!